Hi boys and girls, this is just a short video explaining some tricky concepts that we come across in Mental Maths. The first thing I'm going to explain is the use of coins in Mental Maths. Now, a lot of the coins we come across in Mental Maths are written in capital letters, except for the word pennies. The word penny means 1p. So if we have 8 pennies, that means 8p. Here we have the word twos. That means 2p, a 2p coin. 3 twos means 3 2p coins. Now, we could work that out with a multiplication sum. What is 3 times 2? That gives us 6p. 2 fives, that means 2 5p coins. But another way we could work it out is through multiplication. 2 times 5 equals 10p. 4 tens? Yep, you've guessed it. 4 10p coins, and that equals 40p. 3 20s? 3 20p coins. Now, you could do 3 times 20. That seems quite scary. But you could also do 20p, add 20p, add 20p, and that means the same thing. It will give us the same answer. That equals 60p. 4 50s. I wonder if you can guess that before I write the answer. Well, 450s means 450p coins. Again, you could do 4 times 50p for 450s. Or you could do 50p, add 50p, add 50p, add 50p, counting up 450s. And that gives us 200p. But we don't usually write 200p. In fact, we usually write £2, 2.00. Now, some P4s, quite a lot actually, have the urge to put P at the end of this. So £2.0. But because we have the pound sign, we don't need the pence sign. Okay? Now, moving on, another tricky concept is making the sums balance. Okay? Now, you've come across this where it looks like a gap sum. 7 add something equals 8 add 2, and a lot of children get this wrong because they just add 7, 8 add 2, but that isn't what this sum is about. I like to teach this sort of sum with a pair of scales. Now, this is just a triangle with a line, but if you can imagine this is a kitchen scale, what happens when I put something on this end? That sinks down, and to balance it I need to find something just as heavy on this end so that the two sides are the same, they are equal. And the important thing about this sum is the equal sign. Now, looking at this side, because we have a complete sum, 8 add 2, well that gives me 10. Now if I want the scales to balance, to equal, I need this side also to be 10. But is it 10? It's not at the minute. We just have a 7. So what do I need to add to 7 to equal 10? Well, I need to add a 3. Do both sides balance now? Let's see, 7 add 3 equals 10. Yes, this side equals 10, and 8 add 2 on this side equals 10. So the scales are balanced. They equal the same. Let's move on to a harder sum. 40 add something equals 100 add 30. Let's think of a pair of scales. This side must equal this side, and again it's important to remember that they both must equal. Now, I don't have a full sum here, so I'll look over here. 100 add 30, I know what that is, 130. So if this side equals 130, well then this side must also equal 130. But at the minute, it's not heavy enough, because it's only 40. Now, what could I add on to 40 to get 130? Well, I'm going to add on 60 first. That's going to give me 100. Then I'm going to add on another 30. So 60 add 30 equals 90. Let me just double check that sum and see if it's right. 90 add 40, does it equal 130? Yes, it does. So this side is 130, and this side is 130, and the scales balance. Let's move down here. 70 add 70 equals 110 add something. Again, think of a pair of scales. This side must equal this side so that the scales balance. Now, I've got a complete side here. So 70 add 70, that's an easy one, because what I can do is do 7 add 7, that gives me 14. So 70 add 70 must give me 140. Now, if this side is 140, well then I need this side to balance as well. So this side must also equal 140. But I have 110. It's not equal yet. What could I add on to 110 to get to 140? Well, I could add 30, and that equals 140. So both sides balance, and the scales are very happy.